two application examples of average rate of change. And actually, both of these I'm going to solve graphically. The first case I have to solve graphically. We don't have a method to solve it by hand yet. And this one, actually, we probably wouldn't want to solve by hand because it's a very complicated method. All right, suppose that we have a manufacturer that determines that T months after it introduces a new product, the company's sales can be estimated by that function, or the average monthly sales of the company over the first 6 months. All right, so the first 6 months would be month 0 to month 6, right? Because we always start out at time 0. All right, so we want the average sales from 1 to 6. So 6 would be my B, or not 1, 0 to 6. So it'd be 6 minus 0, or 1/6 if you prefer. I'm just going to go ahead and write that as 1/6. So I'm integrating from 0 to 6 of my n function, which again, we don't have a method to solve this by hand. So this is one of those examples where you have to solve this on the calculator. Alright, so this has to be solved graphically. Alright, we don't have another method. And so that means I've got to plug my y value into my calculator. So 700, make sure you're careful. Divide by your 2x squared plus 25. So again, we plug that into the graphing calculator. So I got to clear out what I have in here. And so we carefully plug that in. So 750x divided by the square root of 2x squared plus 25. Alright, 0 to 6 meanings I don't have to change my x values, but I might want to change my y values. And if I look at my table, I can kind of see my table. It's kind of nice thing about this is I can see my table. It looks like my 10 goes up to like 500, so I'm going to go to my window here. And I'm going to leave everything 10 and negative 10. I'm just going to change this y value to 500. Let me see if I get the picture. Alright, so there's my function. Ooh, so it does go quite a big. Alright, so I see it there. And so I'm integrating that from 0 to 6. So second trace 7. Lower value 0, upper value 6. It's a pretty big area, 0 to 6. Alright, so then I'll probably just go out the 4 decimal places that the problem gave me here. Alright, so solve it graphically. So again, we graph the function, you show the picture. Alright, if we solve it graphically, 0 to 6, shade that area in. That area came out 18.3217. And so remember, don't forget, it's really easy. If I'm going to forget something, I'm going to forget that 1/6. So remember, the answer is not that 18.3217. The answer is that number times a sixth, right? I have to take that sum, right? This is the sum of all the function values from 0 to 6. We divide by 6 to find the average. So don't forget, it's really, if I'm going to forget something, I would forget the 1/6. So make sure you're careful from, don't forget that times 1/6. Which comes out to 303.05. Alright, so the average monthly sales is about 303. I'm going to assume it doesn't say dollars. $303.5 per month. Alright, so on average, they make $303 per month in sales. Right? Some months it might be higher than that. Some months it might be lower than that. Over the first 6 months. Alright, but that would be the average. And it didn't say dollars, but I'm assuming it is. Alright, next example. Which actually, this is one like one in your book. I actually put it here because a lot of times I get questions on this one. Alright, so this one's kind of it's got 2 throwback questions. Throwback to what we did earlier in chapter 3. Alright, so suppose I've got the temperatures in degrees Celsius over an 8-hour period. Alright, so again, from 0 to 8 would be my domain. Given by that capital T function. Alright, so in degrees Celsius. The first one is the new stuff, right? The average. A. Find the average temperature over the 8-hour period. So from 0 to 8, right? For the 8-hour period. So we want to find the temperature average from 8 to 0, which again, that's just 1/8 of that function, that temperature function. which again, you can solve it by hand or graphically. Just make sure you're careful. It is an ugly fraction that comes out. I actually don't think this one's too bad by hand because of 0. When you plug this in, it comes out to 928 over 3 minus 0, right? When you plug 0 and you get 0 out. And then times an 8, which comes out 116 over 3, or approximately 38.66 repeating, is the average temperature. All right, so the average temp from over the 8-hour period, over the 8 hours, is about, since I am going to end up rounding, 38.67 degrees Celsius. All right, sometimes it might be higher than that, sometimes it might be lower than that. That's its average. All right, so that's the new part. B and C are actually throwback questions, right? What's the minimum and maximum temperature? Well, it's a closed domain. We're starting at 0, stopping at 8. And so B and C is actually what we did in Chapter 8. B and C, we want to find the absolute max and min temperature from 0 to 8. So what you have to do is, well, find any criticals over 0 to 8, which means find your derivative. So again, this is a throwback question. Find your derivative of your temperature equation. So go back up here to your temperature equation, find its derivative. So you get negative 2t plus 5. Set it equal to 0, so 5 equals 2t, divide by 2, divide. So there is a critical value at 5 halves, or 2.5 hours. And since it's a closed interval case, my maximum and minimum temperatures either occur at my end point 0 or 8, or at my critical number. And so to test, well, you just plug those in. Find the temperature at 2.5, find the temperature at 0, and find the temperature at 8. And so again, I'm going back to the original temperature equation, which was negative t squared, not x squared, negative t squared plus 5t plus 40. And I'm plugging those values in. So 0 is easy. At 0, it was 40 degrees Celsius. 8 and 0.2, I have to plug those in. All right, so when I plug 8 in, I get 16 degrees Celsius. And when I plug 2.5 in, I get 46.25 degrees. So again, those are my temperatures vary. And so the maximum would be here. That's my max. And the minimum would be there. And so we have a maximum temp of 46.25 degrees Celsius at 2.5 hours. We have a minimum temp of 16 degrees Celsius at 8 hours. All right, so again, the last part of that is a throwback question. And students forget, you kind of have to remember what we've done before, because sometimes we'll do that to you. All right, and so this is one actually in your My Lab. This is what they're looking for. And actually, I think they have 2 different types of this where they ask you for max and mins. Remember, max and mins can only occur at the end values or the critical values. All right, so either the end points or the critical points. All right, you can solve those using the methods we used in Chapter 3. All right, so that finishes up 4.4, applications of integration, which actually we're done with the applications of integration. The last 2 sections, or actually the last 3 sections in Chapter 4, are just more techniques of the derivative, and then we get into one special type of application in Chapter 5. All right, so we'll stop there.